Hello everyone, welcome back to another video for the series. I'm Inohyu and today I brought a problem from IMO. Actually, the second round for KMO ended last Saturday and I don't feel like that bad about it. I'm just hoping for at least bronze because I really need bronze medal to get into to participate in next events like APMO, FKMO, and MOP. So I think if the graders are kind and with God's grace, I might be able to get bronze. So shout out to everyone who took KMO, and I really want to say uh, thank you for your efforts and great job. Because preparing for KMO and other national med Olympiads is really difficult. And actually today we have AMC going on, so good luck to everyone taking AMC. I'm also going to take AMC 10B today, so I'm quite worried. No, not like, no, I'm quite worried because there are a few awards that I want to get. I'm not sure if I can get them, so please pray for everyone who are taking AMC today. Even though KMO ended, I'm planning to finish this series because I said I'm going to make 100 videos for the exam. But even though it ended, I just want to finish the series. So, um, actually, the results come out at December 15th. So, I think if I finish this series, then I might get the results. So, I mean, if I get good result, then this series would be a great practice for I think most people taking KMO or the next one. If I didn't get a good result, then it's fine because I anyways can study and we can make videos about math problems. So yes, let's start. Also, one more thing, sorry. It's been a while. I think it's been like 2 weeks since I started this poem. So if I tweak a bit, please be forgiving. Let ABC be a cyclic quadrilateral. Uh, a that look like a circle. A, B, C, D. Let PQR be the foot of perpendiculars from D to lines BC, CA, and AB. Oh, so you say PQR is a Simpson's line. Um, I don't know. Let's say this is A, B, C, D. No, I'm not sure. I think if we, I'm just gonna draw it like this because I think we need to redraw it anyways. P, C, A. It will be just this, I guess. So this is P, oh wait, B, C, P, Q, R. So PQR are they are collinear because it's a Simpsons line. I think I made a previous, I think I made a video about Simpsons line before, so please check that out. Anyways, PQ, QR, so that PQ equals QR, so that these two lines are equal to each other if and only if the bisectors of angle ABC meet ADC, bisectors of angle ABC and ADC, so they meet on segment AC. So here, they meet here. Okay, I know the drawing is quite messy. Let's draw them again because we got the grasp of it, how to draw them. This looks like a good circle. Yes. Let's call this, before we define D, let's A, B, C. Because there was something mentioned about the angle bisectors, let's consider them while drawing them. One more from here to here. Ah, yes. Angle bisectors of ABC. So the angle bisector of ABC is from here to midpoint of AC. This looks like a midpoint, I think. ABC and ADC. So they meet here. ADC is the midpoint of this. So the angle bisector is from here. Oops. Is from here to, so that is D. That's D. That's D. Let's finish our quadrilateral. A, B, C, D. A, B, C, D. Now let's draw the perpendicular lines. Here to here. That looks perpendicular. From here to here. Oh, alright, so there is a really funny thing that happened when I was taking the exam. In South Korea, uh, there is a middle schooler who became the representative, and her name is Yoon Haewon. She's really famous. Yeah, she appeared on the news for being the youngest, I think. Yeah, I'm not sure, but I think she is the youngest to get gold medal in the IMO in South Korea. I mean, I think the youngest person is uh, the mathematician Terence Tao, but she is also the youngest to get gold medal in South Korea, I think. And uh, yeah, we took the exam in Seoul National University, but she was actually in the same classroom. So when I entered the classroom, I met her, and I was like, "What? Why is she here?" And she was taking the same exam. I think she was, yeah. I'm not sure if I'm allowed to say this, but um, yeah, she was there. I got her signature, and I was so happy. Yeah. Anyways, here's P, Q, BC is P, Q, R. Yeah, I also met other very famous teachers there. I personally was not able to go to their academy because, I mean, like specialized academy for KMO is really expensive. So I was not able to attend there, but I met the teachers. I was not able to talk to them, but I was just so honored to meet them. We need to prove that PQ equals QR, so red equals blue, if and only if the bisectors of ABC and ADC meet on segment AC, here. Now, let's prove the if part first then. So, let's say that they meet here. I forgot how it went. Um, should we chase angles first? I think that will be more helpful. Let's chase some of our angles. Because I remember using the information that we found by chasing the angles. Mm, um, mm, mm, mm. Yes, yes, I think I remember how it went. Mm, yeah, so I'm going to draw a few lines, and the reason why I'm drawing this is because we want to utilize the fact that these are the angle bisectors. Yeah, so because this is the angle bisector, this is the angle bisector, this to this equals this to that. Then we don't have to use this. Sorry, never mind, I'm not going to draw those lines. So we know that because this is an angle bisector, this to this equals this to that, and this to this equals this to that. Because we have this and this, maybe we might be able to use that fact. Let's say that. Okay, let's prove the if part. If the angle bisectors meet at AC, say E, oh, ABC, PQ equals QR. I was quite lazy, I just wrote it like this. Please note that we should not be writing like this during our test. Then we know AD to DC equals AE to EC. We also know that AB to BC equals AE to EC. What, really? AE to EC. Meaning AD to AB equals, oh, this is true. Mm. 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 80 to AB equals DC to BC. These two triangles look similar. DQP and DAB. Maybe. Let's call this dot. Then naturally, this is also dot. Naturally, yeah, how do you find the angle of this? Oh. Let's don't do that. Let's use the fact that this is 90 degrees. This is 90 degrees. Oh, maybe. Let's call this angle dot. This is 180 minus dot. That is I'm confused. Which angles should we use? This angle equals 90 minus this. 90 minus this angle. Yes, I think you're almost there. You're almost there. We just need to prove that this angle. Let's just try. I'm not sure. First of all, this angle, including is equal to this angle. What is the angle bisector? This is single. Wait, what? No, this is single bisector. What? Oh my goodness. I just found one more fact that we can use. Okay. This is 90. Oh, this is 90 degrees. This is 90 degrees. This is cyclic. This is 90 degrees. This is cyclic. Okay, I'll write them. DQAR, DQAR, DCPQ, PQ, and DPBR. Cyclic. Nice. Oh, this is very nice. DQAR. Okay, let's use. So DQAR. DQAR is cyclic. Maybe. Okay. Let's say this angle. No, not good. Let's call this angle red. Then using the properties of cyclic, this is also red. What was cyclic? Because this is cyclic, this is also equal to that angle. Wow, nice. So this angle is equal to that angle. Let's also try that one. This one. this one, the blue equals this, but because since they are cyclic, this is also equal to that angle, this angle. Because it's equal to that angle, this, nice, really nice, I love it. Triangle ABD is similar to triangle QPD. By AA similarity. This is true. Nice. Then naturally, let's call this black. Then this is also black because black is red plus blue. This is red plus blue. We are almost there. Should we find this angle or this, or let's call this green. I just chose this one because it looked easier to find. This is cyclic, meaning this is also green. Because this is green, this is also green. Nice. Meaning triangle DBC is similar to triangle DRQ AA. Nice. Now because they are similar, let's write let's write our ratios. So ABD, so AB to AD AB to AD equals AB to AD equals PQ to QD. But AB to AD equals BC to DC, right? Are they equal to each other? Yeah. And BC to CD, BC to DC is also equal to RQ to QD. But since we know that they're equal to each other because it's an angle bisector, PQ to QD equals RQ to QD, cancel out. Therefore, RQ, this is Q, sorry, equals PQ. RQ equals PQ. Okay, now let's reverse it. If this is true, this is true. But if this is true, and we already know that this is true by default, meaning this equals that, meaning this is true. If this is true, this is true. And if this is true, then this is true. Wait. Let's change to E and F. E and F. We could write it as AE to EC and AF to FC. But since AE to EC equals AF to FC, so E is congruent to F, therefore the other one is true. So the second one is reversible. and that completes our proof. Oh, nice. Yes. I think this is what they did in the official solution. Don't quite remember, but I think this is what we did because what they did because I remember chasing angles and using the similar triangles. So thank you so much for watching this video and good luck to everyone taking AMC today. And tomorrow I'll come back with another very fun and interesting problem. Thank you and see you tomorrow. Bye.